Possible mistakes in Alex Hormozi's leverage analogy. How funny that I wrote mistakes with a mistake. I intended this as email to Alex Hormozi, yet I couldn't find a way to contact him in that form or on social media without a paywall, so I decided to post the email here. Hi Alex, I think your lever analogy in this recent video, how to get so rich you question the meaning of making money, might be slightly suboptimal. Following your assumptions, error and correct answers seem somewhat incorrect. I could only insert 2 images until I reached maximum email file size. I therefore continued in the attached PDF. Here the most critical part. If we pull the lever in each image once, the resulting travel distance you laid out seems disproportional. Here, if we assume you pull the lever with an angle, double the angle until you reach the horizontal line, then both images would look like this. Your answer, very high. Red line, actual distance traveled. Here you give the answer low. The full-length version in screenshots due to formatting. In your recent video, how to get so rich, you question the meaning of making money. You draw the analogy of salary being a lever. If you want to make more money, you need more leverage. You need to get more for your time. You need more leverage. So far, so good. The problem arose for my intuitive following when you then added an arm that pulled the lever. You define leverage as the difference between what you put in and what you get out. Wikipedia for mechanical levers. Levers can be used to exert a large force over a small distance at one end by exerting only a small force effort over a greater distance at the other. You even have the distinction of how much force the arm pulls by using a weak and strong arm. You proceed to ask high or low output, setting up the length of the lever as the distance traveled on the other end. Given the application of a weak force, weak arm doesn't influence the travel distance length that you seem to have set up as scaled by output, then the distance traveled is probably not as high as marked, assuming one pull, simplified for fixed volume. You ask high output or low output, your answer very high. Higher or low outputs. Here you answer low. Here outputs, high or low. If we assume you pull the lever with an angle, double the angle until you reach the horizontal line, then the travel distance in both images would look like this. 1. Your answer very high. Red line, actual distance traveled. Seen here. Your answer very low. Here, red line again is the distance traveled. Now, first, I thought you additionally made the distinction between thinner and thicker errors to account for the product volume times leverage. In other words, the travel distance as of the fixed travel distance multiplied by the number of repetitions multiplied by the force with which the lever is pulled on the other side. But you only introduce the volume times 1000 example later. Let's look at some examples. You tell me how high output or low output. Low outputs here, high outputs. Again, Wikipedia. Levers can be used to exert a large force over a small distance at one end by exerting only a small force effort over a greater distance at the other. Here we again see a picture from Wikipedia. But even if you set up the output as volume times leverage, thereby implying volume as a product of force times travel distance times number of repetitions, your answers, graphics still seem exactly wrong, or reverse. Alex definitions, work equals outputs. Outputs equals volume times leverage. Plain speak, number of times you do something times how much you get out of each time you do it. For simplicity, we now assume 1. Volume is set to 1, since visual representation lacks portrayal of additional reps. 2. Leverage equals set, as shown in pictures. 3. Force is bimodal, strong or weak arm, and seemingly on the other side, not visually included in your slides. How much you can lift. Then here, high or low, outputs. 1. Volume equals 1. The level of the lever also brings up an arm wrestling table as potential analogy, but this would introduce 3D space. Leverage, longer compared to the other pictures. Arm is weak. This gives us the red lines as travel distance of the theoretic object moved on the other side. Here. Not your error in both cases. And if the error is scaled linearly in length, the greater the output, then this makes the two images still not proportional in travel distance on other end and output. In the second image we have volume 1. Leverage shorter compared to other pictures. Arm is strong, but according to you, output is low here. Output, red line, high or low. If you set up your argument the way you did, using two variables plus lever length on one side plus lever length, then the simplified output on the other side should also scale proportionally, even though it is missing the variables of force, as in weak or strong arm. In short, the problem with your analogy might be that either your images or given answers are wrong, following the laid out argument. In other words, force times travel distance might have been better visualized by either 1. Thickness of errors as additional variable, accounting for weight of lifted object if continuing the moving object against force of gravity analogy. 2. Moving a forceful object such as maybe a stone against gravity or wrestling an opponent. You could in the future set up your argument like this. Time equals fixed, repetition frequency as variable. So many writing mistakes. Arm strength equals skill. Lever length, how much leverage over skill. 1. Time is fixed. Everybody has 24 hours or a given number of sales calls. 2. Variables to be changed. Strength. Physically force, as in weak or strong arm. Better analogy, maybe internal skill. The better developed the arm. B. Lever length, as in how smart strength is applied. The best skilled sales caller only can lift so many clients in a day without additional leverage, as in your example, maybe other callers that would work for him. 2. Of course, now one could also imply how smart one uses one's skill. Leverage analogy as already implied in skill, but for the sake of your argument, the above-mentioned differentiation seems to make sense. 3. Since your argument now mainly focuses on the leverage, you could also set the travel distance from the pulling arm to fixed, as somewhat visually already implied by the anatomy of the pulling arm. A. And since time equals fixed anyway, one could see the travel distance on the pulling end as one time interval. 1 day, 1 phone call. Varying the balance point in multiple images might be unnecessarily confusing. Then 2 different images with shorter and longer lever, using stone balls scaled in diameter, or simply weight plates as equivalent on the other side, or another arm, the opponent. B. Then first making the pulling arm stronger, goes to gym or an analog equivalent, increasing skill, and is able to pull heavier clients, more weight, but then discovers how to use his strengths smarter by increasing lever length, but not moving balance point placement, is able to pull heavier clients with his now increased strength skill.